In this video, we're going to look at solving equations that are quadratic in form. And equations that are quadratic in form have the form, obviously, of a basic quadratic equation. But instead of just having an x squared and an x and then a constant term, their terms may be x to the fourth, x squared and a constant, or you may even have a binomial that is sort of in there in place of just an x. So the form that they take uses u as the variable expression, and it's going to look like this: a times u squared plus b times u plus c is equal to 0. And of course you recognize that as the general form of a quadratic. That's what we've been looking at, where x was there instead of u. But what we can do with this one is we can allow u to be various variable expressions, like maybe u is x plus 2, or maybe u is x squared, okay? And then that allows you to expand the type of problem that you can work by factoring or by using the quadratic formula. For all of the ones that we're going to have an x to the fourth in that first term, an x squared in the second, and then our constant term here. So for all of our problems, u is actually just x squared, okay? That's what gives us the x to the fourth there, and that first term is the x squared squared. All right, so now we are going to look at how we solve these. You can use the quadratic formula if you like, or you can just factor them as regular quadratics are factored. You'll find that all the ones that you have in the homework, I believe, can be factored. There may be one or two that you do have to use the quadratic on. The thing to remember when you're using the quadratic formula, let me give you a little note here about that. You will have to use x squared equals negative b, plus or minus the square root of b squared minus 4ac over 2a. And that's because our u's here are equal to x squared. And so if we're going to use the quadratic formula to work this, it will need to have an x squared on it, okay? Now what I don't want you to do is get this confused with your regular quadratic, because normally quadratics are equal to just an x instead of an x squared. So this is for fourth degree polynomials only, okay? Okay. All right, so let's take a look at an example, and we'll work at least this first one by just factoring, like we would normally factor a quadratic equation. So let's see, I've chosen a couple. The first one is number 56 in the homework in the book, okay? It's exactly like that one. And the second one that I've chosen is a homework problem that I've changed just a little bit so that it fits the form that we're going to be working with. So if you look in your homework, you will see the same problem as number 56. X to the fourth minus 10x squared plus 9 is equal to 0. Okay? Now, just like with a regular quadratic, the coefficient here is a positive 1. The leading coefficient is positive 1. So I only have to find two factors of positive 9 that will add to give me negative 10. Okay? I don't have to worry about any coefficient on the x to the fourth part, because that coefficient's a positive 1, so it doesn't bother us, okay? The plus on the 9 just simply means that both factors will need to have the same sign, and since I'm trying to get a negative 10 when I add, I'll need both of them to be negative, okay? So when we factor, producing these factors, we will have an x squared there and here, where we normally would just have an x, okay? Because this is a fourth degree, not a true quadratic. All right, my two factors of 9 that will add to give me negative 10 are negative 9 and negative 1. Now what we have to do, we can continue to factor these. Notice they're both quadratic, they're binomials. Both of these are differences of two squares, so I could finish by factoring, Or if you can't factor it, what you can do here is use the square root property to finish. That's probably a little quicker, even if you would normally factor it. So that's the way I'm going to finish these two, because that's just sort of a better all-purpose method for finishing it out if you've got quadratic binomials left. So x squared minus 9 is equal to 0, and x squared minus 1 is equal to 0. Set your factors equal to 0 and then solve them. So it's kind of like what we're used to doing with quadratics. The steps are basically the same. It's just that at this point, our factors that we have left over are in fact quadratics. So we have to work on those with the methods from section 1.3. To do square root property, I isolate the squared part and then take the square root, putting a plus or minus in front of the square root on the other side. So I've got x is equal to plus or minus the square root of 9, so x is equal to plus or minus 3. Okay. Sometimes you'll get imaginary numbers with these, by the way, so just be on the lookout for that. Neither one of these are imaginary this time. Same thing on this side, isolate the square. Take the square root of both sides, putting a plus or minus in front of the number. And so the rest of my answer is positive or negative 1, okay? And if you're in WebAssign, you will have to type every one of those in separately. You have to be real careful in this section in WebAssign because there are answers that you will lose, okay? And if you don't get them all typed in, WebAssign is just going to tell you the whole thing's wrong, okay? So be sure you get them all in there. So if I was doing WebAssign, negative 1, negative 3, 1, and 3. It doesn't matter what order you type them in, just as long as you got commas between all of them. All right. So there's our first one. You can check them if you want to. This is a type of problem that you don't have to check, but you can check if you like. Go back to the original. Don't forget about the x squares when you're factoring these, okay? Don't factor them just completely like a normal quadratic, because they're not quadratic. They're just in that same form, which makes life a little easier on the whole. Let's try one that's a little different. This is the one that I've kind of altered from the homework problem. Okay, so 6x to the 4th, this is actually like number 60, except I have changed it, plus x squared minus 15 is equal to 0. I believe in the book it's maybe x to the 6th and x cubed. 6x to the 6th plus x cubed, I think that's right. We're sticking with just the 4th degree ones. This will factor, okay, but if you'd rather, you can use the quadratic formula on it. That's absolutely fine. If I want to factor it, my factors of 6 are either 2 and 3 or 6 and 1. And factors of 15, 1 and 15 or 5 and 3. Now, I notice that the 15 is negative, so I will be subtracting to get a positive 1, because positive 1 is the coefficient on x squared, okay? And since that's a small number and I'm subtracting to get it, I kind of know that I'm going to need my two products to be pretty close together. And so I'm going to use the two sets of factors for 6 and 15 that are close, the 2 and the 3 and the 5 and the 3. Okay, and I'm going to show you this the same way that I did it in class, where we do the little diagonal crossing out thing. If you don't like that, there are other ways to do this. You could do this by grouping, or you could use other methods. I'm going to take the 2 and the 3, and I'm going to match them up. And I kind of do this in my head. I make the products in my head as I write it down so I can kind of check it before I actually work it all the way out. If I put it where the 5 will multiply times the 2, that'll give me 10. That would leave the 3 to multiply times the 3, which would give me 9. That difference is 1, so that's what I'm going to want to go with. So I put the 5 here and the 3 here, and I do my little cross diagonal multiplication. That's going to give me a 9. That gives me a 10. I need a positive 1, which means that the 9 is the one that needs to be negative. I'll push that negative on over with the 3 so that I get a negative 9 when I do that multiplication. And now my factors are going to be 2x minus 3 and 3x plus 5. set each factor equal to 0. Whoops, sorry, made a mess out of that, didn't I? Equals 0, so 2x is equal to 3. Scoot up just a little bit. X is equal to 3/2. And then I've got, oh, and you know what I did? I left my squares off, didn't I? I'm sorry. Hopefully everybody was at that point going, she forgot her squares. Hopefully y'all remembered that, whereas I didn't. Okay, so that's going to give this, won't change much other than it just needs to be square down here where I am. And then I need to finish it by using the square root property. When you got a square root of a fraction, you are technically supposed to split that up and then rationalize the denominator to get it completely simplified. So let's do that. Square root of 3 over the square root of 2. To rationalize, really easy. Just multiply the numerator and denominator times whatever the denominator is. And that will allow you to lose the root on the bottom. And then you just multiply the top roots together. Alright, that's going to give me a 2 in the denominator, square root of 6 on top. And then for my other one, 3x squared plus 5 is equal to 0, so 3x squared is equal to negative 5. We are going to get a couple imaginary answers here. X squared is equal to negative 5/3. Do square root of both sides. Plus or minus the square root of negative 5/3. I go ahead and take the I out, square root of 5 over square root of 3. Rationalize that by multiplying times square root of 3 over square root of 3. And we'll have the square root of 15 on top over 3. And of course we've got the I. So plus or minus I, the square root of 15 over 3. So we've got, let's see if I can put it on the screen where you can see all the answers at one time here. There's one set of answers, and there's the other set. This one's a little bit more complicated. The coefficients for this one were chosen specifically so that it would work nicely with the 6th power that this one was originally. So when I switched it to the 4th power, that's what got us kind of messed up on the answers here. But that's okay. We still get reasonable answers. They're just a little weird looking because the irrational part of them, they're fractions. They're both fractions. All right, so that's how you do the ones that are quadratic in form. You either factor or you can use quadratic formula, as I said, to get them down to their binomial factors, and then you use the square root property then to finish them on out. Okay.